Hello everyone, welcome to the 5G Technology 2 lecture session. Today we are going to discuss about the PDU session establishment and QoS flow operation in 5G new radio. A PDU, Protocol Data Unit session, is one of the most important concepts in the 5G core. It provides end-to-end connectivity between the user equipment and an external data network such as internet, enterprise network, or any of the cloud. First, we should know what is PDU session. A PDU session is a logical connection between user equipment to 5G core, 5G core to data network. Similarly, data 5G data network to 5G core and user equipment. It allows the user equipment to access the internet, voice over the new radio, video streaming, cloud gaming, enterprise, VPN, and IoT services. One of the user equipment may establish multiple PDO sessions simultaneously. The 5G is a service-based architecture. It uses a modular and flexible service-based framework where network functions interact over standardized interfaces. The major key component of service-based architectures are network function and service-based interface. The network function include AMF, that is access and mobility management function, session management function, and user plane function. Before getting to the concept of PDU session, we should know what is the function of AMF, SMF, and UPF. First, let me describe the component or the concept of access mobility function. As a mobile network comprises many AMF instances, a globally unique AMF identifier is allotted to each AMF. AMF perform a role of access point to the 5G core. This AMF implement NAS ciphering and integrity protection algorithm. As a part of mobility management, the AMF in charge of for managing handover between the G node Bs within the next generation radio access network. In order to send applicable and appropriate event information, the AMF connects to the lawful intercept in systems. Next one, the session management function. It is primarily responsible for interfacing with the decoupled data plane, creating, updating and removing the protocol data session and managing the session context with the user plane function. Next one, user plane function. User plane function is interconnect point between the mobile infrastructure and data network. That is, the encapsulation and decapsulation of GPRS tunneling protocol, that means GTPU, for the user plane, and it is a protocol data unit session anchor point for providing mobility within and between the radio access technologies, including sending one or more end marker packets to the Genome B. It does application detecting using service data flow, traffic filter template, and three tuple protocol, service side IP address and port number, packet flow description received from SMF. It does traffic usage reporting for billing and the lawful interception collector interfaces. Next one, the service based interface key component communicate via services interfaces rather than the direct connection. It allowing for decoupled data plane and control plane for, and also it supports the flexible interactions. The network functions register with the service repository to allow dynamic discovery for the services. So this diagram represents the PDU session and QoS flow, how the establishment or the session establishment is occurred between the user equipment and the data network available in a user plane. So the PDU session establishment procedure, the establishment process consists of signaling between user equipment, G-Node B, AMF, SMF and UPF. First step, the user equipment first register for the 5G code via G-Node B to AMF. So the AMF authenticate the user based on the registration request. The next step, user equipment request a PDU session. The user equipment send the PDU session establishment request. That information consists of PDU session ID, data network name, NSSAI, that is Network Service Selection Assistance Information, and session type. Finally, the requested SSE mode. The step 3, AMF select SMF. This AMF select SMF for appropriate session management function. The next step, this SMF creates the session via allocating the IP addresses, select the UPF and create the session context, create the quality of service rules. The UPF create the tunnel ID and GTPU tunnel. N2 session setup. This N2 session setup, SMF ask AMF. SMF ask AMF to create the N2 session. The AMF instruct the G-Node B to establish radio resources. The G-Node B create the data radio bearer. The description about the data bearer, we can look at this quality of service architecture. This quality of service architecture includes 3 major terminal, user equipment terminal, node B and then user UPF. And the PDU session establishment between the UE and UPF, different quality of service flow will be available. The radio bearer is present between the user equipment and G-Node B. So the colorful version of the same QoS architecture we can see here. The user equipment, G-Node B and UPF. The radio bearer, data radio bearer is present between the user equipment and the G-Node B. The role of data radio bearer. The DRB is the radio link level bearer inside the PDU session that actually moves the data packet over the 5G air interface according to the quality of service. It is a crucial logical channel that securely bridge over the user equipment and the 5G base station carrying actual user traffic. The core role of DRBs are user plane traffic transport, quality of service enforcement, SDAP mapping, that is service data adaptation protocol, and resource management. Resource management means a single device can be allocated multiple DRB to manage different data streams. Example, a highly sensitive voice call sharing resources with a high bandwidth video streaming. SDAP, that is Service Data Adaptation Protocol, means the layer sits on the top of DRB acting as a traffic cooperation that maps various incoming quality of service flows into the suitable DRB. Specific or critical services can get their own dedicated DRB. Quality of service enforcement, the 5G manages quality of service via IP level flow rather than rigid 4G barriers. The DRB acts as a radio pipe for this flow, ensuring packets receive the required priority, latency and reliability based on their 5G quality of service identifier. User plane traffic transport. While signaling, the radio bearer manages control information. DRB handles the actual application data flowing to and from the devices. The next one, the function of GTPU tunnel functions available in a quality of service. It is a N3 interface user plane link between G node B and the UPF, and it uses GTPU tunneling to carry the user data packets. The major role is user data encapsulation, tunnel identification. For in user data encapsulation, it wraps each user IP packet into the GTPU PDU. This packet is sent over the N3 tunnel from G node B to UPF. Tunnel identification. In each tunnel is identified by tunnel endpoint identifier. The tunnel endpoint identifier tells the receiving node which PDU session or quality of service flow the packet belongs to. The next function is multiplexing and demultiplexing. Multiple PDU sessions can share the same physical N3 link. GTPU allows the multiplexing of different sessions and flows into a single IP link, and demultiplexing at the other end of TAIDs. End-to-end quality of service, it supports packet DAC for specific quality of service flow. It helps maintaining latency, priority, throughput requirement of the 5G quality of service parameter. Transparent IP transport. It does not modify the user's IP packet payload. The tunneling of the packet from the user equipment G node B to UPF, and UPF to G node B. Next, G node B to user equipment. Mobility support. When user equipment moves between the G node B to GTPU tunnel, N3 can be re-established or redirected to support the seamless handover without breaking the PDU session. So this shows the 5G quality of service architecture, the different type of quality of service flows. Quality of service flow with guaranteed bit rate, and QoS flow with non-guaranteed bit rate, delay critical GBR, reflective quality of service, the different type and its operation functions, and how it can be classified, what are all the different QoI assigned for the 5G QoS identifier. That everything we can discuss now. For the 5G QoI service, conversational voice, real-time gaming, video streaming, interactive data, web browsing, mission critical voice and vehicle to any device communications allot the 5G QoI services 1, 2, 4, 6, 7, 9, 65 and 80. The resource types are, for example, the conversational voice, the resource type is guaranteed bit rate, which gives the high priority with the 100 millisecond packet delay budget. The 5QI service for real-time gaming, 5QI identifier value is 4. Guaranteed bitrate service resource type, it gives high priority, and the packet delay budget is less than 300 milliseconds. In the same way, mission critical services 5QI identifier 65, guaranteed bitrate communication, it gives very high priority with packet delay budget of 75 milliseconds. The standardized 5QI value define packet delay budget, packet error, data rate, priority level and different resource type. Based on the operator may also define the non-standardized quality of service characteristics for different type of deployment method. So end-to-end data flow, the scheduler in the G node B prioritizes packets based on the quality of service profile, ensuring the voice packet experiences low latency while the download uses remaining resources. So takeaway of this video module is PDU session is a logical end-to-end connection between the user equipment and data network.